This is Josh. We're going to be doing operations with radical expressions. Sorry, I want to make sure that I say that right as the title of the lesson. Okay, I already wrote the first one up here, and as always, if you want to stop the video at any time and try the rest of these, go for it. You know all the rules at this point. I'm just going to give you a couple little extra tidbits, but for the most part, you might be able to get some of these done on your own. So let's get through them now together, but as always, feel free to stop the video. You're going to learn a lot more if you pause the video, try it, make a mistake, and then watch what I do and then go, oh, now I got it. So before we get into this guy, let's just talk about what we're doing here. Okay, if I had 2a plus 3a, that would be 5a's, right? Because I'm combining 2 apples and 3 apples to get a total of 5 apples. But what if I had 2a plus 3b? Can't combine, can't do anything. All I can do is just rewrite it again, right? Well, these are pretty much the same thing. So if you look at the square root signs as the a value here on these, that's exactly how we should work through this, okay? And that's what we're going to do. We're going to just combine all the like terms. So I have 5 root 2 plus 7 root 2 is, I don't know, I'll just do it right here. 7 plus 5 is 7, 8, 9, 10, 11, 12 square root 2. And then I have minus 6 square root 2. And again, we're looking at the problem as if those square root 2's were just like a's or b's or x's. If that thing on the back is the same, we're allowed to just combine the terms. So 12 root 2 minus 6 root 2 is, well, 12 minus 6 is 6. And so the answer is 6 square root 2. Okay, circle it, got your answer, done. So now that you know that, and you know that what we're going to be doing is combining these things, maybe try number 2. All right, I'm going to erase this and... oh my gosh, that's a lot to write out. Let me switch markers because that was kind of loud. And then I don't know what happens to my red marker when you're at home for this long. Things kind of start to disappear. I don't know. I think my kids are grabbing markers out of this room. 7. Oops, that's a minus 6 root 11. Okay. So once again, combine like terms. What do I have that's common here? I got my 10 root 7 and a 4 root 7. So 10 plus 4 is 14, square root 7. All right. Then I have 5 root 11 and minus, so always be careful with that sign in the front. Remember, this is always when I do my dots, right? To show that like the symbol or sign in front of the number goes with it. And so I just need to be careful with that. So 5 root 11 minus 6 root 11 is negative. Now, this is up for debate. If you want to put a 1 root 11, that's okay. I think the book does it as this minus, and they just take that out, okay? I think a lot of people believe that, well, you're in Algebra 1 and you need to like not write ones as placeholders, but I think that it's valuable. I think that it's okay. It's not wrong for you to put a 1 here. It doesn't change the value of what your answer is. It's just saying it's 5 root 11s minus 6 root 11s is negative 1 root 11s, and that's it. So either way would be great, perfectly fine. The order of these doesn't really matter yet. For now, I would say as long as you're getting both parts, that's great. If you did move this guy to the front, I would say just be careful that you move the negative sign with it. So it becomes negative 1 root 11 plus 14 root 7. Okay? So just be careful of that little bit. All right. Let's just keep on going. The next one's a little tricky because all the square root things are different. 2 root 18, 2 root 32, and then square root 72. So looking at it, I'm assuming that what they're going to want you to do is get them all down to the same amount of square root stuff, or at least that's probably what's going to happen, and then combine everything once you're done. So I'm just going to go piece by piece, okay? And this is, again, where for some of you guys, if you're going to jam this into like one little box, you're not going to make it all fit. So spread your work out. Work on these one at a time. I got a nice big board here, so I am going to work on this guy first. 18 is what? 2, 2 and 9. And a 9 is a 3 and a 3. I'm going to factor everything first, then I'll pull out all my doubles, okay? So what's a 32? I'll do 8 and 4. 4 is 2 and 2. And 8 is a 2 and a 4. And that's another 2 and a 2. I know I'm going kind of quick through the factoring, but this is where if you want, just pause the video, factor these on your own, and see if you get the same thing that I do. But in the interest of time, I want to try to keep these under 30 minutes, and so I am going to go kind of quick with my factoring and try to make up some of that time where I can. 72. I'll do 9 and 8. 9 is 3 and 3. Yeah, 9's a perfect square, so you could just move the 9 or the 3 out and be done. But I'm going to go the long way. 2 and 4, 2 and 2. And if what I just said didn't make sense, then we'll just keep talking about it, okay? So my first one here, I got 2, and then this stuff here. I got this guy, and this guy. I underline them just so that I know, like, where did I finish with this thing? Because there's a lot going on, and I just want to make sure I have all my, oops, almost missed that guy. I want to make sure I have all my factors. So this one here, can I pull out any doubles? I got a square root 2, square root 3, square root 3. Yes, this guy can get pulled out. So this comes out from underneath the square root sign here as a 3. So now this problem is 2 times 3. Anything left to go back under the square root sign? Yes. Square root 2. All right. Then it's add, so I'll just rewrite that. The next one here, do I have a double? I got a double there. Well, let me rewrite the 2 that I started with. Then I have my double. Then I have another double. And I'm left with a square root 2. Are you starting to notice that I'm ending up with a square root 2 for all of them? If you do, then you're going to be adding all this stuff up. If they're different, if this is like a square root 2, square root 2, square root 7, then you combine these guys and then you just leave that guy on its own. Let's see here. What do I got? Nothing in the front, so I'm adding. So let me just write that out. And now let me pull out the doubles. I got a 3 and I got a 2. And what's left is a square root 2. Okay, so I got a lot of stuff. And you might notice, like, I wrote out a whole bunch of math here. And for me, this was the easiest way to do it because I write out all my factors, I circle my doubles, and then I just rewrite them down below. Then I combine everything. 2 times 3 is 6. And then I have a square root 2. Plus 2 times 2 is 4. 4 times 2 is 8, square root 2. And then I have a 3 times 2, which is a 6, square root 2. So now I'm just combining like terms, right? 6a plus 8a plus 6a, right? It doesn't matter if they're a's, b's, square root 2's, whatever. If it's a common term, we're combining all this stuff. 6 plus 8 is, I don't know, 6, 8, 9, 10, 11, 12, 13, 14, plus another 6 is 15, 16, 17, 18, 19, 20. I know I count on my hands. I just want to make sure you're using the tools that you would use in real life. Some people still count on their fingers. If it works, then do it. Okay, so I end up with 20, and then I have square root 2, and I circle my answer, and I'm done. All right, that was a lot of math. But again, give yourself room on the page. There's so many times when you guys write so small and you're going to miss. If you miss one of these square root 2's, then you're going to be out, okay? And that's why I circle them as I go as well, because it helps me kind of gather the stuff that I'm pulling out and pulling out from underneath the square root sign. And then I just rewrite them as different factors. Notice I do that multiplication sign in between because I want to remind myself at the end of the day, I got to multiply this stuff together. It's 2 times 2 times 2 to get an 8, right? And then the square root 2 just kind of comes along. All right. So let me erase this guy and move on to the next one. Speaking of this morning, I went outside. You know, we were going to go on a walk this morning, and I noticed that somebody had dumped this whole like massive amount of Legos all over our front porch. And I don't know, call me dumb, but I didn't know what to make of it. Wait, we already did that one. I'm so carried away. Hopefully you laughed at my joke. If not, so sorry. Let's just keep on going. Some people are probably going, oh, now I get it. There's always those people, right? Okay, anyways. Multiply this times this. 2 ways to do it. You could just multiply the 3 times the 2 and get a 6. Multiply the 2 times the 6 and get a 12. Factor your 12 and get a 4 and a 3 and a 2 and a 2. Again, I know I'm going kind of quick, but all I'm doing is combining like terms, right? This was all multiply, so I can just do 3 times 2 is 6. I can multiply the square roots together to get that, and then I end up with this guy here. From there, I can pull out a double. So I have a 6 on the outside times 2 times square root 3. Okay? So I combine like terms and I get 12 root 3. And I'm done. Okay? The reason I kind of drew that over here is I wanted to do it a separate way over here. 3 root 2 times 2 root 6. If you have 2 different numbers underneath the square root sign and they don't match, then I guess that's the same thing, right? They're different and they don't match. I would say leave this guy alone. I don't know. It really depends. Some books are going to say combine the 2 square root things and factor it. Some books are going to say, well, leave this alone and then just factor this guy. Square root 2 times square root 3. And now what you have is this whole big multiplication thing. You have a 3 times a square root of 2 times a 2 times a square root of 2 times a square root of 3. So do you see how I wrote that? All I did was take the first part and rewrite it here. Then I took the times sign, and then it was times 2. And then these are the factors, right? So it was this guy times this guy times this guy. I just did 2 times square root 2 times square root 3. Because again, we've already learned that if I bust these apart like that, I can easily combine them to get a square root 6. Now that I have all of this, I can multiply everything out. So I have a 3 and a 2, which is a 6. I have a square root of 2 times a square root of 2. Remember, when you have a square root of 2 or a square root of a number times the square root of the same number, the square roots cancel out, or the sign thing here cancels out, and you end up with just the number. And then I have a square root 3 that I can't do anything with. So I combine like terms and I get 12 square root 3, and I'm all set. I wanted to talk about this way just because for some people's brains, this is a lot better. They're like, you know what? That's already done. Why would I mess with it? And I'm just going to bust this guy apart and then multiply everything straight through. And anytime I have a common thing underneath the square root sign, I just know that they cancel and it becomes another factor outside the square root sign. Okay. So we have this method. It totally works every time, but some people feel like, because these numbers are going to get bigger. What if this was like 14 and 28? It's like, oh my gosh, like now you have this gigantic number that you're making this massive factor tree. So for some people, they'd rather stick with smaller numbers and factor them separately and then combine at the end. For some people, they would rather just combine, leave what's small and then just factor what needs to be factored. And then at the end, figure out what you can match up. The choice is yours. I just wanted to present both methods, okay? They're both perfectly fine. They'll both work every time. Alrighty. So, like I said, most of these problems here are from the book. These are the examples. So take your time with them. There's some good explanations in the book as well, which kind of talk through how I'm getting all these answers. 3 square root 5 times 2 square root 5 and plus 5 square root 3. All right, that's kind of ugly, but that's okay. Well, this is just like, let's say we had 4 times a plus 7, right? Can you do this? Of course you can. We've been doing that like all year. Okay, you take the number on the outside and you multiply it by everything on the inside. You're careful that if this is a plus, then you're good. If it's a minus, then make sure that the value becomes a negative answer or amount. But that's all you're going to do. It looks more complicated because you got square root signs and all this stuff, but that's okay. We'll go step by step. 3 root 5 times 2 root 5. Well, I'm going to write it out right here. I have 3 square root 5 times 2 square root 5. I like to multiply the numbers together first, but it's really up to you. 3 times 2 is 6. Square root of 5 times square root of 5 is 5. So in the first part, I end up with 30. Now I'm going to work on the next part. I got 3 root 5 times 5 root 3. Okay, I'm going to do the numbers again first. 3 times 5 is 15. And now I have square root of 5 times the square root of 3. I can't do anything. I mean, no, oh yeah, I can. I was going to say, if that's a 15, maybe I can. Okay, square root of 5 times the square root of 3 is the square root of 15. Can I do anything with that? No. So unfortunately, I'm pretty much done. So I have my first part, right? This is a binomial. I distributed. So my answer is that. Okay, my answer is 30 plus 15 square root 5. All right, so far so good, I hope. We're using some basic rules mixed with a couple new little twists. The main new twist is the whole thing with the square roots. Again, notice I had a square root of 5 times a square root of 5. The square roots cancel and I end up with a 5. I have a square root of 5 times a square root of 3. The terms don't combine, or I can't, like cancel something out. And so I just multiply them back together, put them underneath the square root sign, and just make it a part of the answer. That's it. That's as far as you can go. Okay? All right. 2 more left on the board. Again, if you want to pause the video, pause it. Let's see what you get. There are a couple little tricks with some of this stuff, but I'm really trying to focus on the basics. I want to make sure that you guys have seen all this stuff before we graduate, and I want to make sure that you can go on next year and say, okay, I remember seeing it, I practiced it, yeah, maybe there's a couple extra little weird things that could happen, but for the most part, this is pretty good. If this is making sense, then that is fantastic. Square root 7 minus 6 square root 7. Well, we could look at this as the same thing as a minus 6a's. 1a, and then again, can you put a 1 here? Sure, if that helps your brain. 1a minus 6a's is negative 5a's. Can I put a 1 here as a placeholder if that helps my brain? Yes. 1 root 7 minus 6 root 7 is negative 5 root 7. And that's it. Okay? They gave us a common square root thing, so then it was really a matter of just adding or subtracting. This one was subtract, and I put the 1 there just because it helps me remember, oh yeah, there's 1 unit of that minus 6 units of the same thing, and so I end up with negative 5. Moving right along. Like I said, this chapter is all about just playing with numbers, moving stuff around, seeing what you can do. Okay, but they're all valuable concepts because we're going to use these rules when we start getting into quadratics, which is just around the corner. Okay, we got 3 square root 5 minus 2 square root 20. This guy I can't do anything with. This guy I can probably bust apart. So let's see what it turns into. Square root of 20, I'll do square root of 2 times square root of 10, square root of 2 times square root of 5, and I think I'm good. So let me just rewrite this and rewrite this. Are there any doubles that I can pull out? Well, let me do my little thing. Let me underline all my terms. Are there any doubles that I can pull out? Yes. So I have this guy here. So instead of it being minus 2, it's actually minus 2, and then times another 2. And then is there anything left? Yes. times square root 5. In the front, I just have 3 square root 5. And it just so turns out that I got a square root of 5 and a square root of 5, so I'm probably going to combine all of this stuff. Negative 2 times 2 is negative 4. So I have 3 square root 5 minus 4 square root 5, which is just negative square root 5. There's no one. If you want to put a 1 there, you can. It's really up to you. I personally wouldn't mark it wrong because either way, you're demonstrating understanding. You understood that this one couldn't be broken apart, but this one could. You factored out a 2. You put it in the front. You multiplied. You had the square root 5 in the back, and then you noticed that they were both root 5s. You did a lot of really good stuff. I personally would say that's awesome. Give you full credit. If you want a 1 there, it's okay. You don't have to do it, but again, it's up to you. All right? Okay, so this was lesson 10.3 with all these expressions and stuff like that. Take your time with this stuff. If you want to watch the video again, I know I'm going kind of fast, then feel free to always go back and just listen to what I'm saying. I'm trying to give you the most practical way to solve these. And like hopefully you've noticed, I'm doing these videos. This is like one take, man. I'm not going back and redoing these again. There's no editing or splicing. I'm just going to do the problems. I kind of look at them just a little bit beforehand, and then we just bust through them because I feel like that's more real, and I feel like that's going to help you guys see my thought process and understand how I'm doing all this stuff. Okay. So once again, send me some jokes. Have a good day.